A U.S. federal court case. Lawyers submitted legal filings citing cases that looked perfect. Proper formatting, believable citations. Only problem, the cases didn't exist. The court sanctioned the lawyers for it. A Canadian tribunal case. A passenger asked an airline's chatbot about bereavement fares. The chatbot gave specific policy details. The passenger relied on them and booked. The airline later refused to refund the passenger, as the policy that chatbot described didn't exist. The tribunal found and held the airline responsible and ordered compensation. An Australian case. An AI system generated false claims connecting a mayor to a bribery scandal, complete with details that sounded credible. The mayor issued a legal concerns notice. The claims made against him were false. These aren't edge cases. These aren't glitches. This is prediction doing exactly what it's designed to do, in situations where prediction is the wrong tool entirely. Today, we're looking at where AI breaks down operationally and what that means for how we use these systems. Let's be clear about what these systems actually do. Modern AI systems can only predict, do not inherently reason, calculate, or verify truth on their own. They generate the most statistically likely next piece of information based on patterns learned during training. If you type, "the sun rises in the system predicts east, not because it understands astronomy, not because it looked at the sky. It predicts east because that word sequence appeared millions of times in its training data. This works brilliantly for pattern-based tasks. Writing an email, the model predicts professional phrasing because it's seen millions of professional emails. Summarizing a document predicts what the key points should look like based on similar documents. But here's what the core prediction mechanism does not inherently do. It does not verify truth. It does not follow logical rules. It does not check its own work. It follows paths of high probability. The system doesn't follow the rules of reality. It follows patterns it learned from text. Those patterns often align with reality. Gravity pulls things down. Water is wet. 2 + 2 = 4. But the model has no way to distinguish a true rule from a frequently repeated mistake. Some modern systems have been trained to express uncertainty, to predict responses like "I am not certain" when patterns suggest that's appropriate. Some have been given external tools like search engines or databases to verify facts. But that verification happens outside the prediction engine. The model predicts what to search for, then predicts how to present the results. The checking itself is a separate tool doing separate work. At its foundation, AI predicts everything else. Uncertainty, expression, fact-checking, verification is built on top of that prediction base. This creates predictable failures in specific situations. Let me show you where prediction breaks down completely. First, high-stakes decisions. Medicine, law, finance, customer service. These fields require verification against reality, checking if a legal precedent actually exists, if a company policy is current, if information attached to a real person is accurate. The core prediction mechanism doesn't do this. It can only predict what sounds right based on similar patterns. In that U.S. court case, when lawyers used the system to find case citations, the model had no mechanism to verify if those cases existed. It could only predict citations that matched the pattern it had learned. Name v, name year. The pattern was perfect. The cases were fiction. In the Canadian tribunal case, the chatbot predicted a bereavement policy that sounded exactly like airline policies because it had learned the language patterns of airline policies. But that specific policy didn't exist. The AI didn't break. It just hallucinated a policy that sounded perfectly official. The facts were wrong, but it was convincingly wrong. The tribunal held the airline responsible. In the Australian case, the system generated claims about a real person's involvement in a bribery scandal. The output sounded credible. It followed patterns consistent with scandal reporting the model had seen during training. But the claims were false. The consequence was reputational harm and legal action. A fake legal case sounds exactly like a real one. A fake policy reads exactly like a real one. False claims about a person can follow the same patterns as true reporting. The output looks professional because the model has learned what professional output looks like. But without external verification, it simply has no connection to truth. Second, deterministic tasks, math, code, logic. These require step-by-step reasoning according to fixed rules. But unless the model is using an external calculator or tool, it's not calculating, it's predicting what the answer should look like. If you ask it to multiply 8,472 times 6,391, it isn't doing the arithmetic. It's predicting digit patterns that seem mathematically plausible. Sometimes it gets lucky. Often it doesn't. This is exactly what we're unpacking in video 5. Because once you understand why this happens, you stop trusting confidence and start demanding verification. Third, real-time and current events. The system predicts based on patterns frozen at the time of training, without external tools to access current information. It has no connection to the present moment. If you ask about today's weather or yesterday's election results, a base model will predict an answer based on similar past patterns, not because it knows what happened, but because it's generating what sounds plausible based on old data. Fourth, cascading errors. Here's where things get dangerous. When an early prediction is wrong, later predictions often build on it. One incorrect assumption becomes the foundation for the next output. Each prediction tries to stay internally consistent with the last. In the Australian case, the system generated a connection between a real person and a bribery scandal, consistent with patterns it had seen during training. Once that prediction was made, subsequent details aligned with it. Each prediction reinforced the last. The system created a fabricated narrative. All because the first prediction had no grounding in truth, and no external verification was performed. This is what we call a hallucination, generated information that is incorrect or unsupported. But that word makes it sound rare or unusual. It isn't. It's prediction doing exactly what it's designed to do. The system isn't lying. Lying requires intent. It's simply predicting the most statistically likely continuation, even when that continuation is false. Prediction and truth-seeking are fundamentally different processes. So here's what you need to understand. These tools are powerful, but only when used correctly. Here's the pattern. AI predicts well when the answer is a continuation of existing patterns. Drafting an email, brainstorming ideas, summarizing a document, generating creative content. It breaks down when the answer requires verification against reality, checking if something is true, confirming a policy exists, solving a novel problem, making a binding decision, calculating anything that matters. If you're asking what comes next, prediction works. If you're asking, is this true? Prediction alone isn't enough. You need external verification. This means we can use these systems to generate patterns, but we must verify facts ourselves, or ensure the system is connected to verified sources that can check the claims. Those lawyers could have used AI to help draft legal arguments, but they needed to verify every citation themselves, or use systems connected to verified legal databases. They didn't. They faced consequences. That airline could have used AI to help draft customer service responses, but it needed to verify the policies were accurate, either manually or through systems integrated with its actual policy database. It didn't. The tribunal held it accountable. That mayor was described by a system that generated claims about a real person without any verification mechanism. The consequence was reputational harm and legal action. You can use AI to draft a contract, but you must verify every clause. You can use it to suggest a calculation, but you must check the math. You can use it to generate ideas, but you must confirm they're grounded in reality. When these tools are used in medicine, law, finance, or customer service, we're not consulting an expert. We're not accessing a reference. We're interacting with a sophisticated pattern generator that does not inherently verify truth, does not understand consequences, and cannot check its own output without external tools. It can help you create, but it cannot, on its own, tell you what's real. Once you understand that everything else makes sense. Remember, AI doesn't think, predicts,